Good morning and hi doctor. We are from group 6. We're presenting to you about our final product which is flour. First of all, I would like to introduce our members that contribute along this journey to make our final product comes true, and they are Muhammad Shami, Azamuddin Musi, Muhammad Shukri, Muhammad Shuhaikim, Muhammad Azlan, and me, John. First of all, I would like to introduce our product which is flour, and I will explain to you about what is flour. Alright, first of all, flour is a powder that made by grinding raw grains and beans, roots, nuts, or seed. And we know that our flour is a natural product made by milling grains, usually wheat, to obtain the flour inside. Okay, we use the flour, okay, to make many different food, okay, such as cereal flour, okay, particularly wheat flour is the main ingredient of bread, okay. They are the main ingredient of bread, which is a staple food for many cultures. Besides that, flour also used to mean the flour, okay, the flour or the thinner portion in the meal flour.
Now we move on to anatomy of the grain, which consists of four main parts, which is endosperm, germ, bran, and hairs of brush. As for the function, endosperm is the starchy center which contains carbohydrate, protein in the form of gluten, and some oil. While bran, it is the outer husk which adds texture, color, and fiber to flour. While germ is the reproductive epicenter of the grain and sources of protein. As for the components of several types of flour, the first one is white or refined flour, which uses only the endosperm part. For the wholemeal and whole grain flour, use all parts of the grain, and brown flour using endosperm part with some of the grains, germ, and bran. Wheat, which is the major ingredient in flour, consists mainly of starch 70 to 75%, water 14%, and proteins 0 to 12%. As for the flour characteristics, flour is analyzed and graded for indicators of mining efficiency and functionality properties, including the first one, flour yield. It indicates the portion of the wheat kernel that can be mined into flour, which is a significant indicator of mining profitability. Second one is the ash content, which indicates how well flour separates from the bran. It is expressed as a percentage of the initial sample weight. The third one is flour falling number, which is an index of undesirable enzyme activity that occurs when kernels sprout. Starch provide the supporting structure of bread, so high activity results in sticky dough and poor texture in the finished product. Lastly, the wet gluten index is measurement of the strength of the gluten by index of 0, which is the weakest, to the 100, which is the strongest.
Mechanism of drying. By drying, flour will obtain a stable shelf life. By removing more water and making a very dry product, the cell structure changes, and with that, the product functionalities. This opens a new range of possibilities and applications. Flash drying principle. It is an instantaneous drying using the rapid movement of hot air. Drive the wet material, make the wet material suspended in hot air to strengthen the whole drying process and improve heat transfer rate. Type of flour drying is by using spiral flash dryer. The spiral flash dryer technology is static technology. It makes the drying chamber most hygienic. The most spiral flash technology has no moving parts in the drying chamber. Any risk of ignition energy by metal contact is impossible. It is extremely safe. This is the flow diagram of flash drying.
This is the specific flow diagram for drying. Okay, first of all, the product will enter from the number 1 here. Okay, the material enters the dryer, and then for number 2, okay, it's fresh air. Okay, the flows of air, okay, into the heat exchanger. For how does an industrial flash dryer work? All right, so this causing the clean air entering the heat, okay, heat exchanger at the other end to become dry hot air. So from number 2 here, and then for number 3 is at here, drying column here. Okay, after the hot air enters the industrial flash dryer, okay, it is quickly impacts the material and mixes with the material in an instant, okay, maximizing the contact area between the material and the air to rapidly evaporate water. Okay, this is what happened at number 3. Okay, for number 4, the material enters the material pipeline under the action of gravity and wind and is further dried. Okay, it's entered here at number 4, okay, by the gravity and wind. All right, okay, and then number 5 here, okay, at the end of pipeline here, the dry material is discharged through the discharge port at the lower part of the cyclone. So here is where the place where you can collect your product. Now, issue in flash drying of flour, we have three issues here, which is affect the texture and freshness, which is nutritional value. Number two, affect the color of flour. And number three, too much decreasing in moisture content. Okay, we know that drying is using a lot of temperature, high in temperature, so it will affect the texture and freshness of the flour. Okay, number two. So we know that when our food is heated, when our food is heated in high temperature, a chemical reaction occur between amino acid, which is from protein, and carbohydrate that will cause it to brown. So that browning happened there. So it affect the color of flour. Number three, dry food loses in the water content is usually smaller in size and has more calories by weight. So it will affect the calories in flour.
Now we move on to the next part of the presentation, which is about the other preservation technique that we can use on the flour. So the preservation technique that we use is food irradiation. So for the mechanism, the food is exposed to a carefully measured amount of intense ionizing radiation. This is done in a special processing room or chamber for a specified duration. With food irradiation, the radiant energy, which can be in form of electron, gamma rays or X-rays, will break the chemical bonds, leaving the food still like fresh but with specific benefit depending on the treatment level. Now we will discuss on how food irradiation works. So food irradiation will take place in irradiation facilities. So in irradiation facilities, there is a few parts that we need to know. Like in the diagram, the first part is the irradiation room, where the irradiation process will take place. And then is the irradiation source, which is, for example, cobalt. It will be shielded under the water in the underground tank when not in use, and it will be exposed when the irradiation process takes place. Next is control console, where the treatment is controlled by the speed of conveyor belt, and we can control the amount of energy need varies by the density of the load. And then there is the loading area, where the packaged food is loaded into a conveyor belt for the treatment, and then at the end of the conveyor belt is the unloading process product, where the treated food can be handled immediately, so it can remove from the conveyor belt. And finally is radiation shield, where the facilities is built by a concrete wall to prevent the gamma rays from escaping into the environment. Like I said earlier, there is three radiation energy that can be used on food, which is electron, gamma ray, and X-ray. And the most common source of ionizing energy is cobalt-60, which is a gamma ray. This radioactive material is contained in two stainless steel tubes, one inside another, which will form a double encapsulated called suspenser. These are placed in a rack, and the entire rack will be immersed in a water chamber underground when not in use. When the irradiation takes place or we need to use it, the rack will be raised to expose the radiation. The packaged food product will move along the conveyor belt and enter an inner room where they are exposed to the rack containing suspenser. Energy in the form of gamma ray or photons will pass through the encapsulation and treat the food. So there is two effects on the microorganism in the food, which is the first one is indirect effect and the other one is direct effect. So for the indirect effect, free radicals will form during radiolysis of water molecule. The free radical then will combine with one another or the oxygen molecules. So the unstable free radical will react with the bacterial cell membrane to change or damage their structure, which will lead to bacterial death. The other one, which is the direct effect, the ionizing radiation will kill microbes by damaging their biomolecule of their cell. The incoming photon will hit the electrons in the atom of the microbe or food molecules. So during this collision, photon's energy is transferred to the electron, causing them to collide with the neighboring electron. This will lead to a chemical bond breakage, which will interrupting the normal cell metabolism and division of the microbes in the food. Now we take a look on the flowchart to have a better view on how this process works. So initially the food product, which is flour, will leave the processing facilities and arrive at the irradiation facility to undergo the irradiation process. In the chamber, the product will pass through a beam of radiation, which will kill the pathogen by breaking their bond that hold the DNA together. Next, once the product leaves the irradiation chamber, most of the pathogen are destroyed. And finally, the irradiated flour will go to grocery store or food service facilities to be distributed to the consumer.
IR 4.0 element that can be incorporated into irradiation preservation technique. IR 4.0 elements are network-centric industrial app, quality, safety, automation, monitoring tool, sensor, and industrial IoT. The goal of Industry 4.0 is to introduce automated decision-making, interconnected machinery, data analytics, and more to increase production across the value chain and enable the efficient production of goods. Elements that can be incorporated are Internet of Things or IoT. The IoT can connect various manufacturing devices equipped with sensing, identification, processing, communication, actuation, and network capabilities. Network control and management of manufacturing equipment, asset and situation management, or manufacturing process control allow IoT to be used for industrial application and smart manufacturing. This will reduce the mistake and number of workers to supervise the irradiation machine. Next are smart sensor. Sensor technology enables near real-time monitoring and data collection. it drives data analysis and more informed effective decision making for maintenance, process control, inventory and more. That's all from us. Thank you.